A.2.2 practice 2 assignment, which I've made available today, deals with graphing lines using intercepts. So let's just review what we mean by X and Y intercepts, right? So if this is all total review. You guys have seen this many, many times. The point at which a graph intersects the x-axis, so right there, is called the what? The point where a graph intersects the x-axis is called the, there you go, the x-intercept. Okay, the point where it intersects the y-axis is called the y-intercept. Now, what do you notice about these? So we've got this blue x-intercept and this red y-intercept. Do you notice something maybe important about each of those? Okay, let me give you say it again. Okay, there's a 0 in both of those. Yeah, exactly. So think about what it means, what an ordered pair actually means. I'm going to look at that purple point for a second. What are the coordinates of that purple point? 3, 2. Okay. If an ant were starting off at the beginning, which is at the origin, right? Starting off at home base, how would you give that ant directions how to get to that point? Go right 3 and go up 2. Okay, that makes sense? Right 3 is another way of saying we're going to go horizontally positive 3. Going to the left would be going horizontally some negative amount, right? Going up 2 means we're going to go vertically positive 2. Okay, good. So let's look at x-intercepts for a second. There's one example of an x-intercept, that blue point. But I could take any x-intercept for any graph, and what they all have in common is that they're all on the x-axis. So what would every x-intercept then, what would they all have in common? What would be the same about every x-intercept? The coordinates of that x-intercept are -3, 0. But every x-intercept would have one of those two coordinates in common. 0. Yeah, right? Doesn't that make sense? If you wanted to give an ant directions to go to that blue point, what would you tell the ant? Go left 3 or go horizontally -3. How far does the ant have to go vertically? 0, right? Every point on the x-axis is going to have a y-coordinate of 0 because the ant doesn't have to crawl vertically at all. The ant is only going to crawl horizontally from the origin. Agreed? Okay, well, the same thinking applies to y-intercepts, right? Y-intercepts are all on the y-axis. What is the x-coordinate of every point on the y-axis? What is that? What's the x-coordinate? Josie, what's the x-coordinate of any point that's on the y-axis? 0. Has to be 0, doesn't it? Okay, good. All right, so then we can use a strategy related to this idea that we just reinforced, right? We just reviewed an idea. If I want to find the x-intercept of any equation, so if I've got an equation of a line in any form and I want to find where the x-intercept is, how could I do that? If I want to find the x-intercept, for example, of this equation, what could I do? What has to be happening at the x-intercept? Karma, what happens at every x-intercept, what did we say? There's an x-intercept. The coordinate is 0, right? So y is equal to 0 at every x-intercept. And so if I wanted to find the x-intercept of this line, that if I graph that equation, it's going to be a line. If I want to find its x-intercept, what could I do? Set y equal to what? 0, yeah. I could find the x-intercept by setting y equal to 0. What is this thing doing? What is going on here? Oh boy. It's doing this again. Okay, I gotta restart this thing, darn it. Oh, there it's working. There, it's working. Okay, so to find the x-intercept, I could just set y equal to 0 and solve for x. Okay? If I want to find the y-intercept, what could I do? Yeah, set x equal to 0 and solve for y. Okay? So for example, in this equation down here, I want to come up with a graph of this. And let's think back to what our strategy is for graphing a line. What did we say? Graphing a line's easy. How many points do I need to graph a line? 2. I just need 2 points and then connect and extend, and I've got my line, right? Okay, well, intercepts are points. An x-intercept is a point and a y-intercept is a point. If I started with the blue point and the red point, all I'd have to do is connect those points and extend to create the line, right? So for our 2 points, one strategy would be I could just find the x-intercept and the y-intercept and graph those points and then connect and extend. Okay, so let's try that here. If I want to find the x-intercept, you guys told me that I'm going to set, oh goodness, this is not working. Okay, hopefully this will work now. Let's try this. There we go. So if I want to find the y-intercept, or the x-intercept, sorry, I'm going to set y equal to 0. Now the trick I have here is called the cover-up trick or the cover-up method. All I have to do in that equation then is cover up the y term because y is equal to 0 and just solve for x mentally. Just do a little mental math. Thank you. I'll grab one of those, Julia, right there. One of those guys. So, Ellie, what are the 2 steps to solve for x then if I cover up that y term? Subtract 50, good, and then what? Divide by 2. There you go, good. So if I subtract 50, I'm going to get negative, or I'm going to get negative 50 divided by 2 is negative 25. Everybody agree? Okay. And so I know the x coordinate then of the x-intercept. So there's one point I could graph on the x on a piece of graph paper, right? Now to find the y-intercept. Let's see, Owen, what do I do to find the y-intercept? Okay, good. I set x equal to 0. Okay, if I set x equal to 0, if x is 0, what's 2 times x? 0, because anything times 0 is 0, right? So I can do the same trick. I'll just cover up the x term and solve. That's probably the easiest equation you've ever solved. What's y equal to? 50. There you go. Okay, and we got it. Okay, so our answer is going to be the line. Well, the answer meaning the graph is going to be the line that connects and extends those 2 points, right? Give me 1 to 5. That's no big deal, is it? Right? Easy strategy. Okay. Just for our notes, this is not a really big deal, but just so we can fill out our notes here. We're talking about x-intercepts and y-intercepts. X-intercepts are really important to us in math. We call those by many different names depending on the kind of problem that we're trying to solve. For now, we're just going to call them x-intercepts. But in the future, we might refer to an x-intercept as a root, a 0, or a solution. Okay? Depending on, and you'll understand when we get there why we'd use these other terms. Just depends on the context. All right, let's practice an example or two here. Let's try something like number 4. I think it's number 4 on the back side, maybe. Okay, we want to graph that line. That's our goal. Graph that line. So we need 2 points. Okay, let's use this trick, this cover-up trick, and let's find the intercepts. So Leah, let's find the x-intercept. How about? For the x-intercept, what am I setting equal to 0? Y. Good, I'm setting y equal to 0. So I'll cover up the y term. And now that's a pretty easy equation to solve. 4x equals 8, what's x? 2. Just divide each side by 4, right? Or you just ask yourself, 4 times what is 8? Either way, I get the 0.20. Okay, so we go over 2 and up 0. There's my point. All right. We want to find the y-intercept. Nathan, what am I going to set equal to 0 to find the y-intercept? Okay, the y-intercept is on the y-axis, right? What's always 0 on the y-axis, x-coordinate or y-coordinate? X. Okay, so I'm setting x equal to 0 and solving for y. Okay, so I cover up the x term and I get negative y equals 8. Whitney, what's the solution to that if I solve for y? If negative y equals 8, y must equal negative 8. Good, and I could just either multiply or divide each side by negative 1 to solve for y. Okay? So y, I get the point 0, negative 8, and that's right there. And then all I have to do is, oh, that's a terrible line, but you get the idea, right? There's my line. Okay, give me thumbs. We good? Okay, let's try one more of these. How about number 6? Okay, what makes this one maybe a little bit tougher? Fractions. Yeah, I got fractions there. Okay, so what am I going to do about those darn fractions? Anybody have a strategy? I don't really have to get rid of the fractions, but it sure does make things easier, doesn't it? Nadia, what could I multiply through to clear those fractions? What do you think? I bet you, think you got it? 12? Yeah, does that make sense? I got to multiply by the smallest number that all of the denominators divide into, the least common multiple of the denominators, which would be 12, okay? If we do that, if I multiply through by 12, oh, yikes. Same thing as 12 over 1. Let's see, Ava, can you tell me, what am I going to get from that first term if I distribute the 12 to the 3/4 x? What do you think? What am I going to get, or how could I get it? I'll take either answer. It's 9. I'm going to get 9x. How'd you get that? Okay, so we could just multiply straight across and get 36 over 4, right, is 9. That's fine. Or I could do the trick where we cancel, right? Cross cancel. We're going to reduce the fraction. So 12 over 4 reduces to 3 times 3. Either way is going to give us 9x, right? Okay, what's going to happen if I distribute to the second fraction? I'm going to get negative 4, aren't I? Because I'm going to get, either way, if I multiply straight across, I get 12 over 3, which is 4. So I'm subtracting 4x. If I use the other trick, 12 over 3 is 4. Y, you're right. 4 times 1 is 4, and that's supposed to be a y. And then equals negative 2? Ah, good. There's the mistake that a lot of people made on the test. They did all the hard work of distributing to the fractions, and then they neglected to do the easy distribution to the integer. 12 times negative 2 is negative 24. Okay? So same problem, but at least now it's easier to deal with. We don't have all those darn fractions, right? Okay, so let's find the x-intercept. Okay, to find the x-intercept, what am I setting equal to 0? y. Okay, so I set the y coordinate equal to 0. I'll cover up the y term. Okay, and then if I cover up that y term, oh, darn it. There we go. Cover up that y term. In my, oops, we can go down to our other equation, can't we? We can go down to here. Cover up that y term. I just get 9x equals negative 24. Right? What's the one step I have to solve for x there? Divide by 9. What do I get? Ellie, what do I get then? If I get x equals what then? I'm just dividing by 9, you said, right? So I got, okay, so you're reducing it. You're going a step further, right? So you're negative 24 ninths, which you reduced. You saw that 3 divides into both. You went one step further. I could divide each of those by 3 and get negative 8 thirds, right? Okay, good. So there's my first point. That's a little bit tough to graph because it's a fraction. Now, we always want to write answers as fractions. We never want to write them as mixed numbers, but we might want to think about them as mixed numbers. What would that be as a mixed number? 8 thirds is what? 3 goes into 8 how many times? 2. Okay, so I'm going to get a negative with how many left over? 2, right? 2, okay. Goes in twice with 2 left over, or 2 remaining over my denominator of 3. So negative 2 and 2 thirds. You see the advantage, just makes it, at least if we think about it that way, it makes it a little bit easier to plot that point. So I'm going to go backwards from the origin, 2 and 2 thirds. So there's my, I have to estimate, but that's my first point, my x-intercept. To find the y-intercept, what am I setting equal to 0, everybody? X, okay, good. So we're going to cover up the x term, and that just gives me 4y equals negative 24, negative 6. There you go, good. Okay, so 24 divided by, oops, I know what you're going to cover up that negative, should I? Yeah, there, right? I'm only covering up the first term, okay? So negative 4y equals negative 24. And so what's the answer going to be? 6. There we go. Okay. So 0, 6 is right there. Okay. And if I connect and extend, there's my line.